fairly typical problem in that there's a lot of information you don't know and you wish you knew, and this is about how you set up problems like that. There's two different things. There's you and there's your parents. And so the idea is your parents head out on vacation, traveling at 90 kilometers an hour, and then 30 minutes later you realize that their bag isn't with them, so you decide to place the bag on your roof and off you go. You're gonna deliver it to them so they don't have to come back to the house. So there's the bag. It's got to get delivered to your parents. So they're traveling at 90 kilometers an hour. So they're moving along. At some point, you're going faster. So at some point, you're going to catch up to them. So here they are, here, say, when you finally catch up to them, and then you can give them the bag, and they can be on their way, and you can have your weekend back to yourself. Okay? So the question is, where do we go about setting up this information? And the best thing to do is what we've been doing, and that's set it up, figure out what you know and what you don't know. So there's you, there's your parents, and let's see what we can figure out. So again, the variables we're dealing with in this problem, delta x, delta t, and v. Let's actually move that down just a little so that we can maybe annotate our diagram a little bit. So you, parents. Okay, so delta x, delta t, v. All right, so what do we know here? Well, we do know the speed. So we know when you finally start moving, you're going 110 kilometers per hour. With your parents, they're going 90 kilometers per hour. And then the rest of it is all just not very certain. So I guess one of the things you have to consider is when you start the clock. The way I've drawn it here, if I start the clock now, the instant you leave your house, your parents have already been driving for half an hour, and they've at 90 kilometers an hour, so they've already traversed a certain amount of distance. So you can think of it like at the instant the clock starts, your parents have been driving for half an hour, right? At 90 kilometers an hour. So you can think of that and you can see clearly that that would make it 45 kilometers. So they've traveled 45 kilometers in the time that you were sort of noticing that their suitcase was missing. The place you're going to meet them is up here somewhere. And we don't know this distance. This is not something we can just make up a number for, because that's actually what we're trying to find. That's one of the unknowns. So I guess the best thing to do would be to give it a variable name. We can call it D, we can call it X, we can call it M for meeting up, whatever you want. Okay, but the point is that's the unknown here. So how far do you have to drive in order to go from home to the meeting point? Well, you have to travel this 45 kilometers, and then you have to travel an additional D. So you can write this down as 45 plus X. And how long does that take? We don't know that either. So we're just going to call that T. It's a certain amount of time. We started the clock when you left, and therefore it's just T. Now, your parents, when the clock starts, when you leave the house, they're already here. So they only have to travel D, this is D, not X. They only have to travel the distance D. And the time is the same because you're starting the clock at this instant when both cars are here and they meet there. So the time is like this. So now you can see you have two variables that you don't know the answer to, that you want. And we have, the thing that we know is that these variables are linked by the same expression, v equals delta x over delta t. The speed is equal to the distance over the time. So in this case, what I'm going to do is rearrange that equation and write it like this, delta x equals v delta t, just because it's a more straightforward form, and substitute what I know. So we have 45 plus d is equal to 110 t. That's an expression that describes your motion. How about your parents' motion? Well, same equation, delta x equals v delta t, but in this case, now it's going to be d equals 90 t. So this is the expression that talks about your parents' motion. So what we have here are a system of equations. And how do we solve a system of equations? Well, there's lots of different ways to do it. One way is substitution. So we could substitute d in for there. So we get 45 plus 90t equals 110t. And then we just solve this. So 45 equals 20t, or t equals 2.25 hours. So we get an answer here. But what are we answering? What is this t? Well, according to the way I've plugged it in there, t represents the time since you left, right? So if I was to write a statement for this, I would say the question actually asks when and where will you catch your parents. So for the when, I would say I catch my parents 2.25 hours after I leave, okay? And then to find the answer to the second part, it's just a matter of substituting the time back into one of our equations. So d equals 90t, or 90 times 2.25, which equals 90 times 2.25 equals 202.5. 202.5 kilometers. Again, let's make sure we know what we're dealing with. We're actually solving for d. According to the way we've set up the problem, d actually means this point. So technically, you could say 202.5 kilometers from where my parents were half an hour after they left the house, but that's not very clear. So a better way to think about it would be to remember that they are 45 kilometers from where they are. So you could take that 2.25 and add 45 kilometers, right? And so then you could say, so for the where, you would say, I catch them 247.5 kilometers from home, which is a much better way to put it.